All right, welcome, ladies and gentlemen. My name is Brian McLogan, and tonight is Week 8 Open Q&A. Thank you so much for joining. I have a lot of questions that I want to go over with you guys. And what we're going to do, let me just get that set up. So these are all questions that have been previously submitted. I did see some questions, guys, that you submitted into the chat. I'm not sure if I'll be able to get to everything, but I will try to do my best. And obviously, like other live streams here before, if you have not joined a live stream for me, then please feel free to submit some questions during the chat. If I'm not able to get to it, which is more likely than not, hopefully some other people in the chat may be able to help you or at least direct you in the right direction. So what I at least have up on stage to get started with is how to find the domain of composite functions with square roots. We're going to talk about, again, vertical asymptotes and for a rational equation. I'm going to look into graphing one with tangent, so just using some transformations. I will do well, I'm not going to do the whole thing, but at least I'll set up or at least get the students started with solving a system of equations when you have three unknowns. We'll talk about the dot product of vectors as well as the magnitude of a vector, just kind of go through that. We'll also talk about how to write the equation of a polynomial. And then we'll look into simplifying some rational expressions. And then I'll talk about bearings again. That was another question. So that's what I have in store for this live stream. And then obviously, guys, I always like to, I don't like to say I'm always going to go over, but I usually always go over and try to answer some questions. But I know once I kind of at least go through these, students just start throwing in a lot of questions. So I always just kind of feel bad, but there's nothing else I can really do except for saying, I got to go and just end the stream. So, but again, anyways, feel free guys to always add in those questions. I do try to get into the chat. I've been having trouble the last two streams. I really do apologize for any of you guys that have, said hello or added a super chat. I'm not sure if it was, I guess I was looking, my latency was a little bit off for my stream. So I kind of dialed that down a little bit. And so I think that will obviously, hopefully not make too much of an impact on the stream, but that will at least allow the stream hopefully to be a little bit better. And therefore I can also see your guys' chat coming in better. Cause I was just it was getting in later and then, I wasn't seeing anything and so forth like that. So anyways, just wanted to welcome all of you guys. I do see we got some new people coming in, and then definitely some familiar faces. So that's very good. One average person: David, Vivian, Sailing Cam, Olivia, Evelina. Good to see you guys out, and thank you again for joining my stream. If this is your first time joining my live stream, just to let you know where these questions came from, students went ahead and posted these. I always do I don't always do. I've been trying to be consistent so far in 2020, which I have been, which I'm pretty happy about. And hopefully I can continue that. But I make a community post on my channel every Saturday with letting you guys know when the live stream is going to be, which is every night, Sunday at 9 p.m. And then from there, I just have you guys submit your questions down in that chat. I do ask, though, there was a couple of questions I didn't know what to do, what they wanted me to do. So I had to move past them. And I try to respond to everybody that makes a comment. So I really do appreciate reading some of those, especially some of the nice comments you guys leave. But then from there, that's where I kind of devise up these. And then if I have any more extra time, therefore I'll go and get to them. And Ella asked, do I take any requests from the live stream? I do. It's just very difficult as I'm teaching. I'm going to be in the teaching zone, so I'm not able to look at my chat. So typically it's not until after I'm over with the chats. And then I really only have usually between 5 and 10 minutes to go through them. So therefore, usually a lot of people throw a lot of questions and I can only get to so many. So I try to do my best, but who is that? But Ella, what I would recommend is still type in your question. Sometimes I do scroll back through the chat, depending on how active you guys are. And I'll look for questions that maybe kind of seem interesting or kind of either connected to what we've learned so far in the live stream, or maybe something that's different, because obviously as a math teacher, I do a lot of the same types of problems over and over and over again. So it's nice to kind of sometimes get a variety of something that I haven't done in a while to kind of help me out. So And then, or obviously other people can, help you guys out. So, all right, guys, I am talking way too much. We need to get to some math and then we will cover back up. So then we'll kind of refresh back into there. All right. So finding the domain. Now there's a lot of different ways we could go about this. I think the main idea is when finding the domain, there's one thing is you want to make sure you can identify the domain of square roots, and then also how to identify the domain of composite functions. So the first thing is let's find the domain of f of x and g of x just separately. Let's just kind of cover that. So remember, when we're looking into the domain, we're basically looking for what are the values where the x is going to be undefined. Like what are the values of x you cannot plug in, right? And so we see if we plug in 1, we get 0. Square root of 0 is fine. But any number like 1 or 2, 3, that's going to make our radicand, what's our expression under the radical, negative. So like number 5, for instance, 1 minus 5 is negative 4. You can't take the square root of negative 4. So the process we're going to do is set our radicand greater than or equal to 0, because radicand, whatever taking the even root of the square root, has to be greater than or equal to 0. And therefore I can now just add an x here. And therefore 1 has to be greater than or equal to x. So x, has to be less than or equal to 1, which makes sense. Then I'll go ahead and do g of x, and we'll do the same thing. But this one is going to have a different, obviously, domain, because like 1 actually doesn't work. But you can see like 4, which didn't work here, works here, right? Like 4 minus 3 is 1. Square root of 1 is 1. So again, rather than trying to like guess and check and see where it'd be, just take your radicand, set it greater than or equal to 0. So x has to be greater than or equal to 0. All right. So when we have two radicals, one thing we're looking for is the, kind of intersection. You can see here, x has to be less than 1. Wait a minute. What did I do? X has to be less than 1, but x has to be greater than 3. Well, it doesn't seem like that actually works. So it's either I wrote down the problem wrong, or this one has no solution, or at least there's no domain for f of g of x. Or at least I'm not seeing that. So I didn't work out this problem before, so I didn't look to see if I had that. But anyways, let's go and work into the composite. So now when we're looking into a composite of two functions, basically plugging one function into the other. So for instance, when we're looking at f of g of x, oops. Okay. So there's two things that we're going to be looking for. One, we're going to be looking for what is the domain of g of x, which is x is greater than 3. And that is going to be the intersection with what is the domain of when we plug in that function. So therefore, when we plug in the square root of x minus 3 into this function, we're going to have over 1 minus x minus 3. So now we basically need to figure out the domain of this value, which if that has to be x is going to be greater than or equal to 3, now we're going to be looking for the domain of that, which is going to be the intersection, which again, then I would need to go ahead and set that over to an inequality. So this is one thing I just wanted to make sure I'd work out a little bit more before I get into it. But again, like the same operation applies, like the same rules are not changing. You're still going to have this intersection, but then you're going to also want to go ahead and find, and I just don't have time to go through this and just to verify my answer, but it's going to be the domain of g of x as well as the domain of what is this radicand. So therefore you would square both sides and then go ahead and solve. But I just want to make sure I work on, I want to get to my other questions, but that's going to be at least the idea. And that's the same thing for f of x. So what you're going to want to do is find the domain, or the domain of that is going to be domain of f of x and the domain of when you plug in f of x, which would look like this. So f of x, that'd be 1 minus square root of 1 minus x. So again, all you would set up in this case would be 1 minus the square root of 1 minus x is going to be greater than or equal to 0, and then you go ahead and solve. But again, I apologize not being able to get through. I'd like to just to kind of work through that one because it's not something that I've covered, and I want to make sure I get to the rest of my questions. And that's the other thing too, is a lot of these questions I'll look at and make sure I at least understand the explanation of what we need to do. And then, but some of the questions you'll obviously see actually, 3 of these questions, actually, I'm not going to be able to finish just because I know they're just going to take a little bit more intensive for the explanation. So hopefully I at least got you to the right start. Again, when you are identifying the domain of composite functions, find the domain of, let me rephrase this. You're going to find the domain of the inserting function, the function you're plugging into the other function, that's f of x, as well as the domain of once you plug that function in. And you're going to be looking for that intersection. There you go. Okay, so I was going to talk about this one. This one says f of x equals x minus 5 divided by x squared minus 25. And the student was asking, why is x equal 5 a vertical asymptote? And the reason why x equals 5 is a vertical asymptote is because x equals 5 is what we call a non-removable discontinuity. So what do we mean by non-removable discontinuity? Well, the x minus 5s are going to divide out, right? If you have your quantity here, once I factor my denominator, I recognize that x minus 5 divides out. So even though the function is written as x squared minus 5 divided by x squared minus 25, that function can actually be simplified to 1 over x plus 5. So you might say, well, why would you not just write x plus 5 then if that gets simplified to that? Well, the reason being is because x minus 5, this expression in the numerator and denominator, even though it gets divided out, it still represents a discontinuity. It represents a whole. So for instance, an easier way to understand this would be like, what about y equals x squared over x? Well, if you simplify that, that just goes to x. Well, let's just look at it this way. If you simplify that, goes to x times x over x, right? Which is really just x. However, that's not just the line y equals x. You just can't graph y equals x and say that's the same thing as y equals x squared. Because what happened is we divided out the x. That's a removable discontinuity. And therefore, what that means is that creates a whole. So if we were to graph this, it would look like this. It's still going to take the shape of y equals x, but x cannot equal 0. So that's what I mean by these discontinuities, because discontinuities are values that are going to make your denominator equal to 0 for the rational function. So even though it can be divided out, what happens when it's divided out, that just means it's a whole. But since the x plus 5 cannot be divided out, that's a non-removable discontinuity, and that's why maybe I wrote that. I think I did write that wrong. I think that was supposed to be a plus. That's a plus. Yeah. That was supposed to be a plus. My bad. Or I wrote it either way. But therefore, the x minus 5, I wasn't looking at this. Sorry, I had to copy a lot of these down from there. Yeah. So x equals 5 is the vertical asymptote. Now, again, some people might be confused and saying, well, wait a minute. I'm confused here because obviously you're just changing numbers. The x plus 5 is actually divided out. How is the expression x minus 5 in the denominator, but the vertical asymptote is x is equal to 5? Well, again, it's a discontinuity because 5 or negative 5 is the value that makes the denominator 0, right? When you plug in 5 in for x, that's going to make your denominator 0. So the easy way to identify the discontinuities, even before you simplify it, is just set your denominator equal to 0 and solve, right? So if I had x minus 5 times x plus 5 equal to 0, then I could say x equal to 5 and x is equal to negative 5. And I don't know what I was writing there. Okay. All right. Question number 3 was graphing a trigonometric function. I've graphed a lot of sine for some reason in the past. So I just kind of figured I would do a little tangent one. So just remember, when you're doing tangent, a couple things. You want to make sure you understand what the parent graph is. I'm just going to do the initial period. I'm not going to go crazy. So notice that the shape of the tangent graph, and again, you can identify all of these values by looking at the unit circle, or by using the unit circle, I should say. All right, so this is just going to be one initial period. So between negative pi halves and pi halves, that's going to be 0, and it's going to take on that shape of that nice little S curve. So this is what we call y equals tangent of x. And obviously, again, this graph repeats on and on and on in both directions. So what happens when we take a negative tangent of pi halves minus x? Well, the first thing we need to understand is we want to, if we're going to graph this, we want to understand this as a tangent of bx minus c. Sorry, let's use some parentheses correctly. B times x minus c, double parentheses, plus d. Okay, so first of all, we want the x to be written in front, all right, and if we want a b to be factored out as we can. So what I'm going to do is I'm going to write this as negative tangent of negative x plus pi halves. Now, a lot of people might think that is going to be the final answer, or at least in this format, but it's not. We want to make sure we have that second set of parentheses. So again, this only happens when you have that b, but you want to make sure that you factor out the b. And usually with negatives, that's where a lot of students are going to make their mistakes, is with that negative. Remember, you got to make sure you factor out. Now it's in this format. Okay, so what I'm going to do is I'm going to understand these reflections here first. So it's a couple things. When I have a negative outside of my function, that is going to be a reflection about the x-axis, right? So if you could just kind of take this graph and reflect about the x-axis, now you're just going to have a nice little curve. Thing. Oh, I did have that. There we go. Let's go get that to red. All right, so when I reflect this about the y-axis here, we're going to have a graph that's going to look, you know, something like that, right? And then I have a negative on the inside of the function. Well, that's going to be a reflection about the y-axis, right? So therefore, if you reflect about the y-axis, then that's going to turn the graph exactly to its original position. And that should make sense to you, hopefully, if you recognize that the tangent function is an odd function. It's symmetrical about the origin, i.e. the x and the y-axis. So the only thing that's really happening now is then we also have this pi halves, this x minus pi halves. So what that's doing is that's just shifting the graph pi halves to the right. So then what I'm going to do is I'm going to take this graph and I'm just going to shift it pi halves to the right. So my graph is now, instead of at 0, that negative pi halves with my asymptote, or my asymptote, that pi is now going to be shifted over at 0. I'm now going to have an intercept at pi halves, and if I add pi halves again, I'm going to have a new asymptote. And then the graph is going to take the same shape. Looks really bad like that, but that's okay. So let's just kind of go through the characteristics, because I really don't focus too much on graphing with my students anymore, but I do make sure that they understand how to find the period. Remember, the period for tangent is going to be pi divided by b. So in this case, my b is going to be my coefficient of x, which is 1. So therefore, that's just going to be pi. We also have a vertical, I'm sorry, not a vertical shift. We have a phase shift. And that phase shift is right pi halves. We have a reflection about the x and y axis. And then last but not least, guys, we have to identify where the asymptotes occur. And again, the domain of the function is going to be all real numbers except for where the asymptotes occur. So you can see that the asymptotes here occur at, and this is where kind of the one where we got stuck with a lot of my students. So we can see that the asymptotes of the parent function occur at x equals pi halves. And then the distance they are apart is going to be pi n. And if you look at the unit circle, you could see at pi halves, if you add pi, that's going to take you to 3 pi halves. And that's both going to be undefined values for tangent. However, in this case, I have pi halves minus x is going to be equal to my asymptote. So you can see this is going to be different, right? So when you have a new asymptote equation, or when you have some transformations on the inside, all you're simply going to do is take what's inside of your function and then set that equal to the asymptote equation, which is pi halves plus pi n. Now, again, I can just subtract the pi halves on both sides, and I can divide by -1. Now, dividing by negative, like minus pi halves, pi n, or plus pi n, doesn't really matter. Like, it doesn't matter if you go pi or negative pi, it's still the same direction. So therefore, x is going to equal pi n. So the domain, let's just kind of domain is going to be all real numbers such that x cannot equal pi n. And let's just do the range as well. The range, you can see that the graph is not bounded, right? It continues indefinitely in the negative as well as in the positive direction. So we can say the range is from negative infinity to infinity. All right, next question, number 4. So we'll get into the solving here, and I'm not going to do the whole problem, but I did want to get at least the students set up here. So we have 3 equations, and there's a lot of different ways we could go about this. I'm just going to do the most basic way because the student didn't really clarify what they needed help with. So I'm just going to kind of cover one way, which would basically be using kind of substitution and elimination. So we have 3 variables and we have 3 equations. So we're good. Thank you so much, Kazi Official, for your super chat. I really do appreciate it. Can you go over the rule of adding? No, I cannot. But if you can reach out to me directly, I will see what I can do for you on that. But I do appreciate it. I'm just not familiar with your super chat question to cover tonight. So I do apologize. But I really do appreciate the super chat. And again, please feel free just to reach out to me directly, either on Facebook or on this, and I'll get through it. I took a break here and I'm like, wow, my brain's been going full steam. I see you guys have, gotten a lot of questions going through there. It's whew, a lot. So, I can see the chat moving on there. So it's very good. I'm very happy you guys have a lot to say and hopefully, helping each other, out from this. All right. But, for those of you that have kind of joined in late to the stream, I do have 8 questions that I'm going to be covering here for the rest of the stream. And then I will, get into there and maybe answer, some of your questions here on the chat. All right. So the first thing we want to do though is we need to eliminate our variables. And one way we can eliminate is by using substitution. So the way that I looked at this is I said, well, x equals, well, let's just do 2x plus 3y equals 0. So if I subtract 3y to the other side, then I get 2x equals negative 3y. Divide by 2, divide by 2. X equals a negative 3/2 y. Okay? All right, so x equals negative 3/2 y. Now, the cool thing is, so I now have an expression for x. Now, if I replace x in these 2 equations with negative 3/2 y, well, then now I'm going to have 2 equations that only have y, and z's. And therefore, that's a system of equations with 2 variables, which therefore I can go ahead and use a systems of equations. So that's what I'll do for you. I will at least plug this in. So again, instead of writing x, I'm going to write negative 3/2 y plus 3y minus z equals 0. And then let's do that over here. 8 times negative 3/2 y plus 3y plus 3. Sorry, my penmanship is going down the drain. 3y plus 3z equals 0. Okay, so the 4 and the 2, that divides out. That gives you a negative 6y plus 3y minus z equals 0. Negative 12y plus 3y plus 3z. Okay, so negative 6y plus 3y is a negative 3y minus z equals 0. And then here I'm going to have a negative 9y plus 3z equals 0. So now you can see I have the systems of equations. So now I'm just going to do this. I'll just put them over here. And then hopefully, since you're on a systems of equations with 3 variables, you feel more comfortable solving for here. Now you can solve for y and you can solve for z. And then once you know what y is, plug y back into this equation to solve for x. And you've now found the 3 variables. The next equation was with vectors. The student wanted me to do the dot product for u and u, as well as find the magnitude of v. So just remember the dot product between 2 vectors is the product of the first 2 components plus the product of the second 2 components. Thank you very much, Mr. Beast, for your 99 cent donation super chat. I really do appreciate it. And if you do have a question, bring it to me. I'm more than happy to help you out with that. But again, thank you. I really do appreciate that. So I have u.do. So let's see here. So what we mean by this is if we have -2, 5, dot, not multiplication, -2, 5. So therefore, what we're looking for in the dot product is going to be the first two components, the product of them, -2 times -2, plus 5 times 5. And again, at least in my class, we use a lot of the dot product to just look at if two vectors are going to be orthogonal or not, as well as identifying the angle between them. But we don't get into anything other further applications of the dot product. So in this case, I get -4 plus 25, which is equal to 21. Okay, and since it's not equal to 0, they are not going to be, since it's not equal to 0, then they will not be orthogonal. As far as the magnitude goes, the magnitude of a vector is going to be the square root of the first component squared plus the square root of the second component squared. So we have 4 squared plus -3 quantity squared. Okay, so therefore we'll have 4 squared is going to be 16 plus -3 squared is going to be 9. And therefore you can see that's going to be 25, which is equal to 5. Oh no, chat got disconnected. I wonder. Let me check. Seems everything is going all right. At least it seems better. It's a little bit lower still. Jeez. Okay. All right. Next one is write the equation of the polynomial. Now, I'm not going to get to all of this, write the equation, but I will at least set it up. So let's just kind of go through each one of these. These are all zeros. So what you're going to want to do is write each 0 equal to x, right? Because remember, like when we solve for like the zeros of a polynomial, then one way that we can write them is like x equals this. Right? These are like all the solutions. X equals this, x equals that, x equals these two. So there's some important things that are happening here. Like if I gave you, like for instance, let's just say I said solve x squared minus 1. Well, again, we could factor this to x minus 1 times x plus 1, right? And then we could use the zero product property, right? You can set them both equal to 0. And then x plus 1 equals 0. And then that's when you solve x equals 1 and x equals -1, right? So that's the basic idea from a quadratic, something like fairly basic. So our goal is basically to take our solutions, which we have written down here, now equal x, and write them as a polynomial. So to do that, first thing we need to do is set each of these zeros equal to 0. So we're just going to solve each of these. So this would be x minus 3 equals -I plus I. So x minus 3 plus I equals 0. This one then would be -2 plus 3i. So that'd be x minus 2 plus 3i. And this would be x minus 3 equals 0 and x minus 3 equals 0. Okay, so now once we have them equal to 0, now we're going to write them as a product equal to 0. So we're going to basically multiply each one of these. But here's where things start to change here. Now, again, we're not going to set these equal. We want to find the equation, so y or f of x or whatever you want to call it. The important thing we need to understand, though, is when we're dealing with complex numbers always call on what we call complex conjugates. So therefore, if we have -I, we're going to have positive I. If we have positive I, we're going to have -I. So for each of these factors, we need to make sure we include the conjugate. So x minus 3 plus I also needs to be multiplied by x minus 3 minus I. This one's going to be x minus 2 plus 3i. And this is going to be x minus 2 minus 3i. And this is what happens when we have, in this case, we have x minus 3 times x minus 3. Well, that's really a repeated factor, a repeated 0, which we use for our multiplicity. So this is going to be a x minus 3 quantity squared. Sorry, I need to take a drink. So what I'm going to stop there because basically now what you would need to do, I think I told the student on her spot, I'm like, that's a lot of multiplying. But you need to multiply these out, multiply those out. That's going to give you a trinomial. That's going to give you a trinomial. And that's going to give you a trinomial. So you're multiplying 3 trinomials by each other. I don't have the time nor the patience to want to work through that one. But that's at least, hopefully, again, now you got you set up so you can go ahead and tackle that problem. All right, last 2 questions here, and then I will stay back for a little bit for you guys on the chat. So the next one was just how to like simplify. How do you combine like these? So the first expression is we have x divided by x plus 2 plus x squared. Well, again, you notice that this is a fraction. If I'm going to add a fraction to an expression, it also has to be in fractional form. So what I'm going to do is I'm going to rewrite x cubed as a fraction, meaning x cubed over 1. But the only way you're going to be able to combine these is if they have the same denominator. So what we need to do is find the common denominator. And the common denominator of x plus 1 and 1 is going to be x plus 1. The easy way to find a common denominator is just to multiply the 2 denominators. So 1 times x plus 1 is x plus 1. I already have my common denominator over here, so therefore I'm going to multiply by an x plus 1 on the top and the bottom on the right-hand side. So therefore on the left-hand side, I get x over x plus 1 plus x cubed times x plus 1 all over x plus 1. Now that they have the same denominators, I can just add this as x plus x to the 4th plus x cubed. And you could rearrange those, but for the sake of time, I'll just leave them as that. Now for the next one, you probably recognize I don't really want to multiply an x squared minus 4 times x plus 2 to find the common denominator. So in this case, it might be helpful to see, well, how can I simplify this? And I could rewrite x squared minus 4 as x minus 2 times x plus 2. Now I see that they both share an x plus 2. So they have an x plus 2 in common. So therefore, all I need to do for them to be common denominators is multiply this right-hand side by an x minus 2 over an x minus 2. Now you can see that they have their common denominators. And now again, I'm just going to go ahead and multiply. The other thing you want to do is look into simplifying this, but if you factor out a 2, you're going to get an x squared minus 8, which is not going to simplify or divide anything out. The only other thing that's kind of important here is just make sure you have that subtraction. So if you're going to multiply this, which is fine, just make sure you have 2x squared minus 16 minus, come on, minus, and then what I'm going to do is I'm just going to put this in brackets, this x plus 4 times x minus 2. So that's going to be an x squared, let's see, 4x, so that's going to be plus 2x, and then minus 8. So again, make sure you're going to want to just make sure that negative is outside that product, and that's going to be all over x plus 2 times x minus 2. Okay, and obviously you could simplify this a little bit further, but for the sake of time, since I'm at the end of my stream, I just wanted to kind of get through that. Because the only thing I want to mention, a student asked me about like bearings. I don't have time, obviously, to do a word problem. I do have a lot of word problems coming up. I think my video in my classroom that I recorded, actually, it won't be for this week. It will be for next week. Will be all about bearings using the law of cosines. So for this week, I'll be looking into using the law of sines kind of problem. But I did also do a video, and I think the main thing with the bearings for a lot of students is really just setting up the problem. So I did do a recent video where I covered 28 word problems, just setting up the equations. I would highly recommend that you go ahead and take a look at those problems so you can understand like what to do when you need to set up an equation from a word problem. And my best piece of advice is when you have a bearing, every single time you have a bearing, use a compass heading. So north, east, south, west. So there's a lot of different ways to use bearings, or at least how they're described and how they graph them. But the main thing is use that northeast, southwest. And especially for the law of sines, law of cosines problems, if you have multiple bearings, then sometimes you're going to want to use those geometric relationships of parallel lines in a transversal. So that's where I'll just kind of leave it from there. I do have some more examples for you, but I did want to at least kind of like touch base on there because I don't have time to do a word problem at this point. But hopefully at least just kind of reminder of always drawing those compass headings and drawing the bearings. I think will at least give you on a good foot. And then again, if you're doing the law of sines, law of cosines, you need to have an angle, right? You need to have an angle. For a law of sines, you have to have either two angles and a side, or you need to have that relationship, that ratio. And then for the law of cosines, you need to have either side angle side or side side side. So hopefully that helps. Sometimes you got to do a little bit more of geometry work to be able to find those missing sides for a word problem, but that's it because that's a word problem. So, all right, guys, hopefully I think my chat's still going on. Looks like going back through there. I maybe have just a couple of questions. Ella is still here. How do you find the equation of hyperbola given just the vertex and its asymptotes? Well, I'm not going to have time to cover that. Yes. Shardy says trig is hard. Yes, it definitely can be for sure. So the main thing is once you know, if you have the vertex, so just remember the asymptote equation. And again, it's been a while. We haven't gotten to asymptotes yet. But if I recall, x equals, plus or minus a over b times x minus h plus k. So if you know the equation of the asymptote, basically, so when we have a hyperbola, we need to figure out h and k as well as a and b, right? So if you have the vertex, that's your h and k, or I'm sorry, right? So I'm already giving your h and k. Now you just need to identify your a and your b from the asymptote equation. But remember, the asymptote equations change based on the transverse axis, if it's horizontal or if it's vertical. And again, I'm going off of memory here on these formulas. I believe this is for a horizontal transverse axis, and this would be for a vertical transverse axis. That means the two hyperbolas will be opening up vertically from each other. But don't quote me on that because it's been a while, so I'll have to kind of remember. So, and here we go. Here comes the questions coming through here. All right. Let's go ahead and see. Anyone tell me? Mind linking the bearings video? Yes, I can. Yes, I will post that in a comment as far as the bearings video to set up for you. So, but that will have to wait till after at least I'm done with the stream. And you know what? Let's see here. What else do I have? That's weird. All right. Hey, Greg. Hey, Ribia. Hey, Edward. Hi, Rosie. Hi, Justin. We have the chance to cover polynomial functions and modeling. No, I mean, I'm basically at the end. I don't know why my thing is coming in through this. I do not recognize the Pinchy Donald Trump. I'm trying to see with Mr. Beast. If you can maybe send me, Mr. Beast, if you want to connect with me on Facebook and maybe send me a picture of what you're looking for, I really do appreciate your super chat, but I'm just not understanding what exactly your question is. But you can always reach out to me on Free Math Videos on Facebook and then just shoot me a message of what you're looking for, and then I will see what I can do for you. But I'm just not understanding it regards in the chat. Yes, row echelon method. Yeah, I'm not gonna be able to get to at least row echelon method. I may maybe be able to cover like a question or two, but obviously not something as in detailed or multiple steps as row echelon meshing. So am I nerd being here? Rosie, no, of course you're not a nerd being here. I think I would take the cake of being a nerd if there is a nerd in here, since I am the one that has completed over 1,000 math tutorial videos and gone over live streams answering other people's math questions. So I'm pretty sure I'm the one taking the heat as being the nerd right now. But in seriousness, there was another student that made a comment, as far as like getting help, that, should they not have a tutor? They felt like, their teacher thought that was a bad idea, or they, or maybe not smart enough to be in the class. And I completely disagree. I think it's very, very important for you to be able to get help, even if you think you don't need help. And that's one of the things that I recommend students to do, is just get with people that you can work with. Because there's always that time where you're like, oh, I understand this. This is easy. Maybe I get it. And then like the next chapter can come around and you can be completely blindsided and be like, holy crap, I don't know what to do. And then, your friend that maybe was struggling before might understand it. I've been through those like up and down so many times with different classes. And I think it's so helpful to be able to have people that you can work with and you can ask questions from. And especially ones that you can feel comfortable with, like I know a lot of my students, they don't feel comfortable asking me questions. They don't want to feel stupid thinking like I'm going to judge them for not understanding something, which is completely not the case. But I can see that mentality, students. And, I've had that too, like where I don't want to go to my professor and, let them know that I don't know what's going on in class. So, a lot of times you'll just kind of hide it. Or even you don't want your friends to know that you don't understand what's going on, and I think that's, it's totally acceptable. It's totally understandable. But I think I don't think that's a good recipe for getting by what you need to, cover in for that. So I would just make sure that you have someone or some people that you can work with to ask them those types of questions, that you can feel comfortable with and get help with your math. No, Henry, I cannot. Pitches are a new concept in Algebra 2. It's based on graphing logs and pitches. I'm just not familiar, Mr. Reed. Like I said, if you can just send me like a picture or something, I'm just not familiar with the concept. I know you've asked it multiple times and I've tried like looking up and I just don't see anything. I've taught Algebra 2 for multiple years. I haven't taught it in the last couple of years. So I'm not sure if maybe I'm missing something there. But again, if you want to reach out to me, either directly or outside the stream, I can spend a little more time to help you out. Cause I know you've obviously been with me for a lot of chats and, have obviously been, very, very engaging. So I really do appreciate that. All right. Sean asked, do I do one-on-one tutoring? No, I do not. This is really kind of my only tutoring that I'm able to cover for you guys, just because I still have, I still teach inside the classroom. So I got to get stuff done, prepare for my lessons for up to this upcoming week. I also record a lot of my videos. Obviously, I record a lot of videos at school, but I also record a lot of my videos at home. So I just don't have time to work on anything else, or at least any other projects here on there. But you guys have some good questions. I do appreciate. Sometimes it's just helpful for me after doing so many math problems just to kind of talk about math, but not really actually math problems. But I do apologize. I know there was a lot of you guys that did submit some questions. You wanted those questions answered. What I can tell you guys though is next week, I will plan on going live, same time, same place, 9 p.m. Eastern on Sunday. I will post in the community chat, on my community post with a link to the live stream, as well as a way for you guys to post your questions. And if you guys do have questions, I would love to hear them. I will respond to your questions and your comments, and I look forward to seeing you guys next week. But for now, I have to sign off. See you later, guys. Cheers.